a second project in the make kit that I haven't covered yet, and that is the 555 timer kit. Now would be a good time to explain exactly what the 555 timer is.
Everything inside this blue box here is kind of what's going on inside the timer itself. And then the green stuff that I've drawn out here is the rest of the circuit. So we can kind of...
I'm going to pause it here for a second to sort of get a misconception out of the way. The name 555 timer does not refer to the 5 kilo ohm resistors that are in the circuit. To do that would be to disregard completely the inner workings of the circuit. A better way to think about the 555 is Guy Gardner is not a gardener. He is a fictional character known as the Green Lantern. Karen Carpenter is not a carpenter. She is a musician. And Prince isn't. So in that sense, the 555 refers to the circuit, and it just happens to be a coincidence that it uses 5 kilo ohm resistors.
Through the base of this transistor, so this transistor is off, and so no longer is the capacitor discharging. We're back into the state where the capacitor is charging again. So the capacitor will charge, our output is on, eventually the capacitor will get back up to 3.3 volts. This will switch, we'll start discharging again, and this will turn off. Capacitor will discharge, and it's off. Capacitor will charge, discharge, and so we get the capacitor is charging and discharging kind of like this, but our output here is this nice clean square wave. And that's what we see when we look at the circuit here. We see our LED flashing.
There's more to the circuit, but I think for now this will be enough. Just having this image of having a clean square wave, which would give you a blinking on and off, that's enough information for us to go on. So let's continue. So in the kit we have a DATAC or DATAC 21223 PCB, one length of wire, and 2 LEDs. We also have a battery case that can fit 3 AAA batteries, which I had to buy separately. This is our ST Microelectronics NE555N chip. The NE means that it's at a commercial temperature family, as opposed to the SE, which is military commercial family. That just means that we have something that can satisfy everyday conditions as opposed to military conditions. We also have a non-polarized capacitor with a 104 marking on it. Non-polarized just means that we can put it anywhere and it's not going to matter. The 104 marking, a better way to think of the 104 is the first two numbers, 10 to the power of 4, and that this capacitor is measured in picofarads. So if we were to do 10 to the power of 4, that gives us 100,000 picofarads, or 0.1 microfarad. We also have 2 resistors. Both of them have a brown band, a black band, a green band, and a gold band. All this just means to us is it's a 1 mega ohm resistor with 5% tolerance. We have 2 additional resistors, and these 2 have a brown band, black band, a brown band, and a gold band. For us, this means these are 2 100 ohm resistors with 5% tolerance. And that's our kit. The website for the instructions on building this circuit is located in the book that came with the kit. However, when I typed in the website, this was the message that I got. A quick Google search led me to this site, which I took to be the directions to create the circuit, so this is where I started. My instinct was to use a breadboard instead of a PCB.
For good reason, because you can just plug components in, there's no soldering, you can move things around, and you can generally have a play with stuff just to see if something's going to work before you dedicate it to a PCB, and it's good for experimentation.
The PCB diagram did not line up with the breadboard, so it took me a little while to figure out where the last parts were going to go. It was from here that I had to make some assumptions. The first LED had to go from 1 ohm resistor to the negative charge, and the second LED went from the other ohm resistor to the positive charge. A length of wire goes from pin 4 to the positive charge. Then it was a simple matter of connecting the battery box and turning it on. Did it work? No. For some reason, I just was not getting anything from the battery box. I didn't know why. My first step in troubleshooting this was to check the batteries. So I took out a multimeter and tested all the batteries. The same kit where I got the breadboard had a charger in it, so I decided to use the charger instead of the battery box. So I'm using the one plug that I have in a house. This is an AC power with 100 to 240 input, 5 volt DC output. Standard plug, nothing special. And did it work? Kind of. As you can see, there's no blinking at all. Not the kind of blinking I was expecting with the 555. So I knew I had done something wrong. So I moved some stuff around, and once again, it kind of worked. In a last-ditch effort to get something to work, I used this diagram of the 555 blinking circuit as reference. So did this work? Again, kind of. So in the end, what can I say about this make kit? Well, it is definitely not for the easily frustrated. It definitely is going to take some patience. I'd say that the soldering part was the easiest part, but I am not as fluent with the timer kit. I would need to study putting together circuits and stuff before committing anything to PCBs. What I'm going to do right now is give myself a score, and I'm going to be using something I like to call the non-academic self-test. Y'all. Who am I kidding? I was born Canadian. So what kind of a score can I give myself for this? Well, I have to give myself the green for being able to solder the robots. Even though 4 of the 5 robots worked completely, I would have had 5 out of 5 had I given it some more time. I will not give myself the yellow for understanding the circuit because obviously I don't. I just need more work, and that's it. Thank you for sticking around, and we'll talk again. Bye-bye for now.